Alright, today we're going to do experiment 15, complexometric titrations. In this experiment we are going to use EDTA, which is ethylene diamine tetraacetic acid. We're going to have the EDTA in a buffer of pH 10. So your acetic acids, if you can see, each one of them have an O minus. And so you have 4 O minuses. Now you're going to do make a complex ion. The coordination number of an EDTA is 6. It will coordinate at each negative oxygen and the electron pairs on each of the nitrogens. And so when you have a coordination number of 6, your geometry is going to be octahedral. So instead of writing the giant molecule EDTA, we are going to abbreviate it as a Y minus 4. So our first part of this experiment, we're going to find the hard water, the hardness of the water at QU. All right, so the main component of hard water is calcium ions. Magnesium also a significant component, but for this lab we are going to consider the calcium to be really the only component in our calculations. But there are other components besides the calcium that we get from limestone, which is calcium carbonate. Also some calcium from gypsum, which is calcium sulfate dihydrate. Both of these are insoluble solids, if you have your solubility charts. All right, and so when we look at the calcium carbonate, which we're going to do all of our calculations with calcium carbonate, which is our limestone, it is insoluble, and it has the KSP reaction there, where your calcium carbonate will dissolve into calcium ions and carbonate anions. Now in acid, so acid, for example, acid rain, this is going to increase the solubility of limestone. So as we saw in the KSP chapter, if your anion, the carbonate, is going to react with your acid H plus and form a weak acid, it is going to increase your solubility. And so carbonic acid is a weak acid. And so this is going to significantly increase the solubility of your limestone. And your carbonic acid will also decompose into carbon dioxide and water. All right, so our first titration is going to be the hard water titration. So I'm just going to take tap water from the lab here. And again, we are assuming that all of the hardness is from the calcium, and more specifically calcium carbonate. And so our calcium plus 2 plus our EDTA, which is abbreviated Y minus 4, is going to give us our complex ion, a calcium EDTA minus 2 complex. It's a complex ion, all right. And so our titration equation, mV over C, is equal to mV over C. You notice in the balanced chemical reaction that both coefficients are 1. And so both coefficients are given as a 1. And so our molarity times volume of our water, which is going to be where we get our hardness, calcium plus 2, is equal to the molarity times the volume of our EDTA. Now we are going to make an EDTA solution. All right, and so we're going to take and calculate the molarity of our EDTA, which is moles of EDTA per liter of solution. And so in the directions it says to weigh out about 1 gram, but give it to 4 decimal places. So I have a 1 with the 4 x's there. We're going to have numbers there in a minute. And so you take your mass divided by the molar mass, and the molar mass of the EDTA is given as 372.24 grams per mole. and we divide that by the volume in liters, and we're putting this in a 250 milliliter volumetric flask, and so converting that to liters, it is 0.2500 liters. And so that will give us our molarity of EDTA to 4 significant figures. Now your volume of EDTA and your volume of calcium plus 2 we are going to get from our titration. You can convert them both to liters if you want. You can leave them both in milliliters. The rule here when you have a volume on both sides of the equation is they have to have the same units. Alright, and so for this hardness of water, we are solving for the molarity of the calcium plus 2. Alright, and again, for this hardness of water, we are going to assume that all of the calcium plus 2 came from calcium carbonate. And so the moles of calcium plus 2 equal the moles of the calcium carbonate. There is 1 calcium in the calcium carbonate. And so that was all going to the calcium plus 2 in the hard water. And so if your moles of calcium plus 2 equal the moles of calcium carbonate, the molarity that you found for calcium plus 2 is also the molarity of your calcium carbonate. Now the question is to find the parts per million, so the hardness in parts per million. So hardness in parts per million, ppm, it has the units of milligrams per liter. And this is why it's called parts per million. So a milligram is 10 to the minus third grams. A liter is 1,000 milliliters. Now these solutions, the hard water, is water. The density of water is 1, and so the volume in milliliters is the same as grams. 1 milliliter of water is 1 gram of water. And so we convert our 1,000 milliliters to 1,000 grams. I put that in scientific notation. And so I have my milligrams, 10 to the minus 3 grams, and then I had my 1,000 milliliters converted to 10 to the third grams, just putting it in scientific notation. When I bring my 10 to the minus third, that's in the numerator, down to the denominator, it makes it 10 to the third. And so 10 to the third times 10 to the third is 10 to the sixth. So you end up with 1 over 10 to the sixth. 10 to the sixth is a million. So you have 1 over a million, or a part per million. And so what we are going to do is convert our units of moles per liter into milligrams per liter, because milligrams per liter is a ppm. Alright, so again, to get the ppm of calcium carbonate, you're going to convert the molarity, which is moles of calcium carbonate per liter, to milligrams of calcium carbonate per liter. And so it is a simple calculation. You have your molarity of your calcium carbonate, which you got from your titration. You calculated from your titration. Alright, so that's moles per liter. So to convert from moles to grams, you get on the periodic table, find the molar mass of calcium carbonate. I did that for you. It is 100.09 grams per mole. So now we have grams of calcium carbonate per liter. We want milligrams, so we convert our grams to milligrams, and so we have to have in the denominator grams, so they cancel, and in the numerator we need milligrams, and milli is 10 to the minus third, and so you have milligrams on top, you have 10 to the minus third, which is milligrams on bottom. We are just converting the units. We are not doing anything else, just converting the units from a gram to a milligram, not changing the actual amount, just changing the units. And that number is going to be your answer for your hard water, ppm. Alright, then the second titration that we're going to do is we're going to be given an unknown magnesium plus 2 solution. Alright, and so a magnesium plus 2, which is another component of hard water. Alright, so this was made up as a unknown, is going to react with our EDTA to form the complex ion Mgy-2. Remember, Y is the abbreviation for EDTA. So again, we're doing a titration, so MV over C is equal to MV over C, and we are solving for the molarity of the magnesium plus 2. Now, you will see when we do the experiment that we're going to take the bottle of unknown, and I'm going to take 5 mils of that solution, and I'm going to dilute it to 250 mils solution in a volumetric flask. And so you will have the molarity from this calculation is the molarity in the 250 mils that we mixed. The question is, what's the molarity from the bottle it came out of? So we have to undilute. So to undilute our unknown, we have the dilution is MV is equal to MV. I want to know what is the molarity of the 5 mils that I took out, since I know the molarity of the 250 mils that I made. When you do the titration, that is the molarity of your 250 mils. And so again, when you have volume on both sides, as long as they are the same units, they will cancel. And so in this case, I left them both in milliliters. All right, so now we're ready to start the lab. So the first thing that we have to do is to make our EDTA solution. And so I have weighed out our EDTA. I tared the weigh boat, I put in the white solid, and it gives me a mass, there's a shadow here that is hard to see. All right, 1.0428 grams. And so for your mass of EDTA, it is 1.0428 grams. All right, and so now we're going to quantitatively add that to our volumetric flask, and then we will dilute that to the mark with deionized water. All right. So let's write down 1.0428 grams of EDTA. All right, so we will take this over to our volumetric flask, and we are going to add it carefully so that none of this spills out. All of it goes into our volumetric flask. All right, and so when you got all the solid, you can see that there is still some on the weigh boat. And so when you quantitatively add it, you're going to then squirt some water and get every last bit. So your deionized water bottle, and so you get every last bit, anything that's going to cling to your weigh boat. And you wash it down into your volumetric flask. All right, so that is a quantitative addition. Now, all of the EDTA is now in this 250 ml volumetric flask. All right, so now we're going to put in more deionized water. We're going to dissolve our EDTA. We are then going to fill it up to the mark, and we will have 250 mils of solution. And then I have my two burettes. They are both deionized water wet. Again, we will thrice rinse it with our solutions. And then we are going to be ready for our titration. So for our unknown, which is over here, I pipetted 5 mils of our magnesium sulfate unknown, and this is unknown number 2. All right, so this is our magnesium plus 2 unknown, and I took 5 mils out of here, and I pipetted out 5.00 milliliters, and then I put it in the volumetric flask, and then I filled it to the mark with deionized water. And so I am ready with my unknown. And so we're making our EDTA here. We need to dissolve all of our EDTA. And I have a beaker. for both the unknown solution and for the EDTA solution. So the directions say to get a cork stopper and to shake it up. We are not going to do that. To thoroughly make sure it is a homogeneous solution, we are going to put it in a beaker, and then it will be completely homogeneous. When you're adding the last bit of water, the water is going to go up the neck, and this is going to not be the same concentration as down here. And so I'm going to pour it into the beaker where it will mix freely. Alright, so I'm just dissolving the EDTA. It's looking pretty good. Fill up the deionized water here, using it all up. Still have quite a bit of solid in there that needs to dissolve. All right, so I'm going to get my water sample ready. And so I'm going to just take the tap water. And I'm going to use a burette rather than a pipette. Seems very odd that I'm going to thrice rinse my burette with tap water, but that is what I'm going to do, right? It's wet with deionized water right now. And so I'm going to put some water in there. I'm going to grab a beaker. And I'm going to open the stopcock, going to rinse out, make sure that this is all wet with tap water, not with deionized water. All right, so I rinse it once. Rinse it twice. All right, so now this is all wet. This is all wet with tap water. And so now we're ready to fill this up. Magnetic stir. I keep coming back to the magnetic stir. That would make things faster. You can't really use a magnetic stir. All right, but I could use it for my titration. But all right, so I opened up the stopcock to get rid of the air bubbles. I'm ready to fill this up and get my initial reading. Make sure there are no air bubbles. There's one here. And now if it splashes out on me, it's not acid, it's not base, it's just tap water. And all right, so that looks great. So ready with my tap water. There's the rest of my tap water. All right, still dissolving my EDTA. It's getting there. Each time I swirl, more and more dissolves. All right. Very close. All right, so I'm going to prepare for the titration. All right, so I weighed out the 1 gram. We now know what it is to 4 decimal places, and then I am dissolving it. All right, so we have our water sample. It's just from the tap right behind me here. It says the pipette. We are going to do the burette. And so we will get ready for our titration while our EDTA is still dissolving. So in 125 mil, volumetric flask, we are going to take 0.2 grams. Well, first we're going to put it in the water. All right, so we're going to take our initial reading. The initial reading is 0.32 milliliters. All right, and then I'm going to add I'm going to add about 22, 23, just in case I pass up the end point. I can add a couple more mils of my deionized water. All right, so it is now at 22, oh wait, yeah, 22.95, 22.95. All right, so about 22.5 mils in there. All right, so now to get this ready for the titration, we have to add a lot of different stuff. So it says you have your, it says 25 mils. We have our 22.5 mils. We will calculate it exactly. We're going to add some ascorbic acid. Still some solid EDTA in there. So we're going to add 0.2 grams of ascorbic acid. We're going to add 1 ml of pH 10 buffer. And a small scoop of the indicator, EDTA indicator.